And welcome back. So I got a request on my last video to show a little bit more about the functions of a voltmeter. Now, there are many types of voltmeters. Some that are geared to very specific purposes, some that are geared to a wide range of purposes. And what you need to use a meter for, depending on the speciality, will sometimes dictate the type of meter and the type of function. So I just want to put that out there, that making a how-to video on a multimeter is a pretty wide topic, and I'm not here to say that you should use a multimeter this way or that you shouldn't use it or which one you should use. You kind of have to make the determination what you're going to be using the meter for and how you will be using the meter in that application, and that will kind of guide you. Now, what you see sitting here on the table is a fluke meter. It's not the cheapest meter you can get. It's also not the most expensive one that you can get, but it's better than average tier, I guess I would say. Now, what I'm going to show you is the basics that I use a meter for, and there's going to be some functionality on this meter that, at least in this first video, that we won't cover here. I again just want to show you the basics of what I use it at least for in the automotive work that I do. Now, I use this meter for more than just automotive work. I use it for checking voltages and such on the solar system, doing electrical work around the house, so on and so forth. Now, because this fluke meter you see here, much like most standard meters, has a wide range of functions where it can be used in multiple applications. Fluke does make a meter that is more specific to automotive. Now, it is higher price, but it also has some functionality this one does not. Like, it will actually graph certain waveforms on the meter, which is pretty cool. But again, you're getting into more of that specialty niche, where if you want to start looking at certain waveforms of sensors just at a basic level coming off a vehicle, you could use an automotive type meter more for that suited purpose. There are also some meters that have 1 and 2 channel oscilloscopes built into them. Again, more if you want to look into what the actual crank or cam position sensor is doing and you want to actually see the waveform. That's what I mean when you get into more of that specialty niche in which it's now could possibly dictate the type of meter. But again, I just want to kind of cover some of the basics here. So what you see on the table is a Fluke 117. What they call true RMS. RMS, I don't want to go into it on this video because I'm not 100% expert in it, but there are a lot of other good videos on YouTube that if you just search true RMS, that'll give you a wonderful explanation as to what a true RMS meter is versus a non. But for what we're going to do here, just never mind that piece of it. But it is a Fluke 117. I've had this meter for probably 12 to 15 years at this point, and it's never lost a beat. This particular meter, and I'm just grabbing something here off the side to show you a bit later, again, is one of these all around, has enough functions on it that for your average use of a meter, it'll probably do just about everything that you could want it to do. I'm going to start off with a very basics here, and you'll notice most modern multimeters just have a selection switch for what you're looking for. So you'll see a V with a wavy line above it. This is your AC volts, and it also measures hertz in this case. Again, don't really need AC when it comes to dealing automotive. You've got the V with the solid line and the dotted line underneath of it. That means DC. And I've got you zoomed in, so hopefully you can see this. You have a millivolts AC scale and DC scale. You've got resistance, continuity, which will also measure your resistance, a diode checker, and you also have amps AC down here at the bottom. Let me slide it forward a little bit, and amps DC. So you can see this meter will, like I said, it's one of the stereotypical ones, which you kind of get a lot in just a little bit of a package. Now, there are some older meters out there which they don't auto range. It doesn't auto select like if you're on resistance. Now this one you can manually switch the resistance range, which I'll show you here. But there are some older meters out there where you have to set it, like say for instance, if you know that you're measuring resistance, you have to set it to the value you're looking for. In those cases, and I will say this, you typically start with a lower resistance range on the manual knob, and then you kind of go up a little bit, and up from normal resistance to ohms, to kilo ohms, and then to mega ohms. But again, we're kind of getting beyond the basics here. But most meters you're going to buy nowadays are going to be digital. They're going to have a selection knob on it, and most of these functions will kind of auto range on their own based on what it's in. Against, for example, on that, if you flip this over to resistance, it will auto range itself. So if you're measuring something in high resistance, it'll go between ohms, kilo ohms, and mega ohms on its own without you having to tell it to do it. But one of the more basic functions that is, let's say you're just out and you're troubleshooting a light out on your car, and you want to see if you're getting voltage at whatever you're currently testing at. If I come down here to, let me just raise that up so hopefully you can see that. You'll see a volts DC right here on the side. And what I've got sitting off here to the left is just a little laptop bench power supply. It's currently set to about 12.5 volts. And we're just going to hook these up. Now, any multimeter you buy is going to have negative and positive leads. When you're dealing with DC, most meters, you can hook them up backwards, and they'll be fine, again, because we're measuring just voltage here. So I'm going to deliberately do that. I'm going to show you that this meter is going to snitch on us. You see that it's still reading the 12.54 volts that we've got our bench power supply set to, but you'll see the negative symbol in front of it. That's letting me know that I'm measuring volts DC, but I've got my leads hooked up backwards. That's also another good way that you can verify your wiring diagram in your car. If it tells you, let's say pin 1 should be battery positive and pin, let's say 2 should be ground, and you hook them up and you see the opposite of what it should be, that either means that your wiring diagram is wrong or something's wrong with your connector. So let's hook this up correctly. And you can see now we're reading a positive 12.5 volts. Now, you'll notice again earlier this measured negative, because there are cases that you might be using a meter where you're going to get a negative voltage value, and that's perfectly normal. But typically you see more of that inside of a computer power supply or any type of computer in general in which negative rail voltage is commonly used. And the automotive side of it, you're typically not going to find a negative referenced voltage if you're just checking out a light or a light socket or 12 volt power to a radio. Now, it may, an automotive may use negative 12 volts, but typically it's not going to be in anything that you're accessing or would need to check, like maybe inside the gauge cluster where you have logic circuits, or inside the PCM, or various control modules within the vehicle. If they need a negative voltage, they will more than likely generate that on their own via internal power supplies. But again, just kind of keep that in mind. Most things you're going to check on an automotive vehicle aren't going to show negative voltages by default. Again, most modern vehicles, ground is going to be your negative, and then you'll be reading battery positive. But that's not case for 100% of vehicles. Some vehicles out there, much older ones, that actually run a positive ground to the chassis. Just kind of be mindful of that. But anything you're checking, especially if it's within the last couple of decades, will be a negative grounded vehicle. So keep that in mind. If you're troubleshooting an item that is negative grounded, like you saw in our last video, I was making comments about a body ground and a chassis and or frame ground. What that is, and Scott Rods made an excellent comment on the last video in reference to specifically the bed of the vehicle as well as the cab. You have to keep in mind that most modern vehicles, not just on trucks, the bed and the body could be isolated or are isolated from the frame, usually by some type of rubber bushing to help with shock absorption, make the ride better for you. By doing that, manufacturer has to make sure that all parts of that vehicle are grounded to each other, meaning that the bed and the cab, in a truck's case, as well as the metal chassis or the frame, are all tied together on the same ground plane. Otherwise, really weird stuff can happen, especially in a modern vehicle where you're driving a lot of sensors and you're driving a lot of computers, because if you get into cases where you have what's called a floating ground, weird stuff happens, like you saw with our hazards, where the hazards were on and they were working, but it was also flashing the backup bulb, which it shouldn't, because part of that vehicle wasn't grounded to the other half of that taillight circuit. So what was happening was it was trying to find a path to ground through another device. So when you're measuring ground, and this is where your negative lead comes in off your meter, it's typically okay to go to like a metal bolt or a metal fastener if you know that fastener goes through and goes into like a body panel or into a frame. You just want to verify that whatever you're hooking your negative lead up to is a solid and secure ground. One of the ways you can do that is if you can take a positive lead, if you know for a fact you've got a good battery positive off a pin, you can take your negative lead and maybe touch it to a door hinge or to a bolt that goes through a door hinge or through a bolt that's going through a metal bracket around wherever you're working, and just see that if you get 12.5 volts, worst case scenario, you can run, and you would need probably a pretty long test lead to do it, but you can run a test lead directly from battery negative and test that way as well, if you had to. I prefer to go to a chassis ground or a body ground or some kind of bolt that's going to a body or chassis, just so I can verify I've got ground. Just verifying that the chassis is grounded and or the frame and or the body are all three to each other. That's a little bit long-winded, but I apologize. But kind of getting back to this, we're just measuring standard voltage here. We're not doing anything fancy with the meter. We're not doing anything fancy with the settings that you see up here. Now, you see a min-max. If there's interest in this, I'll definitely go deeper into this. But like I said, a lot of these functions and features, if you're just using this for straight up automotive work, you'll probably never use it. But I'll be happy to go into more of these if there's interest in doing so. But again, we're just measuring voltage. So again, the V with a solid line above it and a dash line above that. So you've got your solid line, a dash line, a V below it. That is your volts DC. And you can see on the meter here, let's get that a little closer to the camera. It's going to be an LED display, so I don't want to twist it too much, otherwise you won't be able to see it. But you'll see volts DC typically show up inside the digital display somewhere. So again, that was volts DC. Now, What you saw me testing with in the video was a continuity check, which most newer meters within the last 10, 15, even 20 years ago, maybe older, all have some form of a continuity checker. I like the digital ones for this because the digital ones typically may emit an audible beep, and I'll show you what I mean. So I'm just going to disconnect our meter. Whenever you're dealing with a meter, it's just my habit, and I understand it's also good practice. Disconnect whatever you're testing before you rotate this knob. Because if you're still connected like we were to a power source here, and you click it to a setting that wasn't meant to register power, you could inadvertently damage something. So again, always make sure you got your test leads disconnected. What I'm going to do is come down here to this symbol. It looks like a little bit of kind of like a bunch of squiggly lines together. Almost looks like it's like you would see sound waves being drawn off a diagram coming off a speaker. But you'll also notice, if you look at the display, you have a resistance symbol. Now this is typically what's called a continuity checker, and what I'm going to do is just touch the two test leads together. You notice you get a nice beep, but you also get a resistance reading on the screen. That's what I was doing when I was testing the grounds. Because according to the wiring diagram, the driver's side was grounded to a ground point in the cab. The passenger side was grounded to a ground point on the frame. And like we spoke about earlier, bed and cab and frame or chassis, whichever you want to call it, should all be tied together in some way, shape, form, or another. That's why I was testing, because I knew that even though one was grounded to the frame, because everything's metal, one was grounded to the cab, if everything was okay, you should be able to go from ground on one connector to ground on another connector and get a continuity check. And when we didn't, then we knew we had a problem. And by that I mean, again, these two test leads are just plugged straight into the meter. There we go. That lets us know our test leads are good. And we can also do this. Bring in a little example of show you a little example of what I was referring to. So I'm going to slide the meter out of the way, slide it down a little bit. There we go. We got a bolt hooked up to an open-ended alligator clip, you see here. We also have a washer hooked up to our yellow alligator lead, which clips onto the metal washer. Slide the meter out of the way a little bit more just to get some more real estate, because I don't care about the reading. I just care about it emitting a tone at this point. There we go. So you can see we've got this green alligator clip that comes over here, clips in the bottom of this bolt. The other side of this bolt comes over here to another jumper, clicks on this side of a metal washer, then from this side of the washer to the other half of another alligator clip. That completes our chain. So if you think of it this way, this is what I was doing yesterday, is that if this is our passenger side alligator clip, and this bolt, or washer I should say, represents our frame ground, and the entire frame is made out of metal, and we know that the other side of our connector, which is this other green alligator clip here, is connected to this bolt. That was from our driver's side tail light. And this is connected to a cab ground. Then this cab should be grounded to also the body. And what this represents here is either a ground strap or some other method that the manufacturer's chosen to do so to ground everything. So again, if I now put our meter in here, so you can see we got our red one on that one over here, we got our black on that over here, we have continuity. But what we were getting yesterday was basically this. So it was like this part of the connection going from frame to cab wasn't connected. We were getting nothing. And that was the point in the video that I was showing you, that I found a ground point on the frame behind the front driver's side wheel. And because that was missing, that wasn't allowing the cab to ground to also tie into the ground of the frame. So when I tightened it up, basically we just facilitated that. So again, kind of like I said, my best way to kind of describe what was going on there. And as to why we were looking at that ground, and we knew that when one didn't reach the other one, even though according to the wiring diagram, now that's an important point, according to the wiring diagram, they all ended up on a ground plane that should have been tied together. Now, with that being said, one thing you have to watch out for, I'm just going to get these disconnected here and kind of get this out of the view and put our meter back up, is that there are some circuits that are grounded. I shouldn't say grounded, but they are what they call negative side switched from the PCM. You're not going to be able to necessarily do the same check where you check the negative side of, let's say, a fuel injector, which may be negative side switched, and go to ground, because it goes through the PCM, will more than likely go through some type of transistor driver or some type of driver circuit, and that's going to throw your readings off. So just keep that in mind. What we were testing with here and what we're referring to is using the continuity on the meter to verify what should be a body and or chassis ground, something that per the wiring diagram is going to a ground plane. With that being said, other things you can use the continuity checker for, which come in handy. You got a standard blade fuse here, and you can do this with just about any automotive fuse. We just take our leads. Let's get this more in the shot. One lead on one side of the fuse, one lead on the other. And if the fuse is good, we get a beep. So it's just a real quick, basic way of being able to test a fuse. Now, this is out of circuit, what they call out of circuit. And before you go use the meter in continuity mode to check this fuse, pull it out of the fuse box first before you do it. Because you don't want to inadvertently send 12 volts up your meter when it's in continuity mode. Because remember, when it's plugged into a fuse box, there's a strong likelihood that one half of this fuse is going to be live on 12 volts. And the other half only will be if the fuse is good. But if it's blown and you put a meter in here on continuity mode, you're basically bridging the circuit and turning your meter into a new fuse or a path for connectivity. So if you're going to test these, pull them out of circuit, because being in circuit could cause you some problems if you're not aware exactly what's going on when this is plugged in. Let's see, another thing. So again, that was just a real quick kind of definition of what you can use a continuity for. Again, you can use continuity to verify that from a ground pin on the connector to a body ground, you have continuity, and that will at least verify that that is a good of enough connection you're getting a beat. Now, one thing to keep in mind when you are doing that is check your resistance reading. Like yesterday, you'll notice, I shouldn't say yesterday, but in the last video, you'll notice that when we first did taillight to taillight, ground to ground, this didn't beep, but we got a resistance number on here where we didn't expect it. So if you're troubleshooting a ground in a harness and you go to do that, maybe you don't get a beep on the meter, but you get a resistance reading. That could be an indication that you've got a high resistance connection between the 2 points, and it's something you kind of need to look into. As well as fuses. If almost forgot to cover this. You can do it with a light bulb as well. Again, we're just one on the base of the bulb, one on the tip, and we're just verifying the filament within that bulb is good. Again, another quick check you can do: pull the bulb out of its base, do a continuity check on it, and if you get a good continuity signal, then there's relative to say that the bulb's okay. There are exceptions to that rule, where if the bulb blows but fails shorted, then the continuity will make you think it's good when it's not. But it's kind of a rare case, but it can happen. Let me switch things up a little bit. Slide the meter forward. Now I'm going to turn the meter off when I do this, and there's the reason why. I'm going to slide my red lead over to this port. You can see there that's labeled 10 amp fused. This is another function, or the second, or I should say third function, that I use a lot, at least for automotive use. And it's going to be the amperage check. Remember earlier we made a note that amperage DC was down here, at least on this meter on the bottom, solid straight line, dotted line underneath, and then a letter A. So we want amps DC. I'm going to put that back down and turn that off and cycle that back, because I want you to see what the display does. Notice the display said lead momentarily. It's a good reason, because it's trying to tell you that on this particular meter, the positive lead has to be pulled out of what you would normally have it in if you're measuring continuity or voltage or resistance, would go here, and it has to be swapped over to this side. Because what it's going to do is you're going to put this meter in line with whatever we're about to measure, and it's going to tell you how much current is flowing through, and it uses a little shunt inside the meter to do this. This particular meter, as well as is pretty common for a lot of them, has a 10 amp limit. It is fused. I'll show you an example, at least in this Fluke's case, of what it uses for an internal fuse. Show you that there. And what this is a specialty fuse that is got, I believe it's sand, if I remember correctly, that's inside this fuse. So when this fuse blows, it's got sand to help extinguish any potential arc that may continue. Because if you inadvertently plug, let's say you leave this in, for a couple reasons for it. Let me go into that. The reason why these fuses are special, and the reason why they're in there, and this is, if you're going to be doing amps in a meter, this is where you want to make sure you got a quality meter that's got a quality fuse in it. Because, like I said, it contains a silicate or a sand to help extinguish any type of an arc that might form. When you have a meter in amp mode, always remember that you have it in amp mode. You don't want to try to measure voltage with it or use another task with it, because having a meter in amp mode, if you're measuring voltage, is pretty much almost a dead short across whatever you're measuring. So you can imagine if you were measuring a car battery or measuring an AC outlet, and you still had your test lead pushed over to measure amps, and you're pretty much dead short what you're measuring. These fuses are designed to potentially break and absorb that, which is why they're kind of pricey to replace, and they're special purpose. And the reason why I have these, and ask me if you want to know, but yes, I've done that. I've left my lead, positive lead, over here on the amp setting and went to measure a battery, and let's say it blew the fuse immediately, thankfully. But getting back to what we were going to do, we're in amp mode. I'm going to take my meter. We got a little simulated load here. along with our laptop power supply. Just going to push this LED a little bit out of frame just so it doesn't blind you. There we go. Okay. So I got to flip these around, sorry. Okay, there we go. So you can see that we now have a reading, 0.162 amps. That matches our laptop power supply. Our bench power supply is actually saying 0.17, but 0.164 is close enough. But you can see what we're doing here. Let me move you around a little bit. We got our positive lead connected up to our load directly. So from, let's get that pushed off to the side just so you can see this a little better. Positive lead connected directly up to our source and destination, so basically our power supply and our load. But our negative lead comes off of our power source, whether this be our bench power supply or our battery, hits the negative lead on our meter, comes out of the positive lead of our meter, and then goes up to our load. You can see that there. And you can see doing that, let me get you zooming back down here, you can see the meter is telling us how many amps this little backup LED bulb is pulling. You can use this method to check various loads in the vehicle. Now remember, you're limited to 10 amps. So you don't really want to exceed that, because otherwise you will blow this fuse, and they're about $5 to $6 a piece or more to replace. Because again, they're specialty fuses, so they're kind of high dollar. What you could use this for is, let's say you're troubleshooting, you probably heard this before, called a parasitic draw. That's when the vehicle is off, maybe you got all the doors closed and you're waiting for the car to go to sleep. Car or truck to go to sleep, whichever you're driving. You can put your meter in line with the negative battery connection. Because typically most modern cars, when they're in sleep mode, maybe 20, 30, 40, 50 milliamps, somewhere around there, something that's going to be very, very small, that a standard 10 amp capable meter would be able to show you. So if you put so again, what you'd do is that you would disconnect the negative lead off the battery, and this would get attached to the negative lead on the battery. So you'd hook this up to your negative lead on your meter, would go to your negative post in your battery, and then the positive lead out of your meter goes to the negative terminal for the vehicle, the one you just took off the battery. So again, you're putting your meter in series with that circuit, and that'll show you. And let's say you wait 20, 30, 40 minutes. Most newer cars, sometimes it's an hour or more we have to wait before everything goes to sleep. Let's say it's been a couple hours, and you look down on your amp meter, and you know per the documentation you should be in sleep mode. Maybe the documentation tells you no more than 40, 50 milliamps should be consumed while the car is asleep. But you see, let's say 2 amps, let's say 3 amps, then you know you've got something inside that vehicle that is not sleeping. And you can go on from there. And you can kind of use this same process and put the meter in line with any circuit that you want to check to see what the amp draw is. Again, keep in mind, 10 amp maximum on this particular meter. If you have to exceed 10 amps, then you're getting into doing shunts, current shunts, and then you measure the voltage across the shunt and use it to calculate what your amperage would be. To give you an example, and I know this is going a little bit off topic, but just to show you one here, this is a stereotypical DC shunt. This one is rated for up to 500 amps. This is one of the types of shunts I use on the solar system. What happens is you put this in line with the negative between your source and your load. You measure the voltage between these two terminals, which will usually come out in millivolts, and then you could use that millivolt to calculate your amperage draw. So instead of the meter being in amp mode like it is now, you'd move your red lead back over, you'd be in voltage mode, but in this case you'd be in millivolt mode, because you'll notice we have a millivolt setting, and you'd get the millivolt reading across this shunt. But again, that's for something a little bit later, and if you want to drill into that or see a demo of that, I can easily set that up and show it to you. Let's see. So again, what we are is we are measuring current on this meter of how much it's taking to run this bulb. Now, what I'm going to do is I'm going to disconnect this LED bulb. I'm going to temporarily just touch it to this incandescent bulb you saw us testing earlier, just to show you. Hopefully you can see that. 1.7 amps now to drive this turn signal bulb. So in case you're curious, you could use it for that method too. If you're, let's say you're adding lights to a vehicle and you want to verify that, okay, I'm going to add a particular set of tail lights or change the bulb in a particular tail light, and I want to know how many amps a new light is going to pull. Well, you can, get yourself a temporary 12-volt source, hook your meter up in line through whatever you want to test, and the meter will tell you definitively how much current that bulb will pull. So you can kind of compare that with the standard one that was in there before you upgraded it and figure out, do you need to beef up the size of your wiring? Is the fuse that's already in line with that lighting circuit going to be able to handle the extra load, and so on and so forth. So a lot of cases in which you can use the DC amps on a meter. Now, when you're running in DC amps like we are here, before you move this back to off, always disconnect your meter, which you can see that we've done here. It's no longer connected up to a load. Now I'm going to take it a step further because we're in amps, and again, just being cautious, I'm going to take my red test lead out. I'm going to turn my meter off, and then immediately take this test lead, the red test lead, and put it back on its normal position. And again, the reason why that is, and I've done this and I've seen several other individuals do this, is that you don't want to forget this lead's been swapped over to your amp side of your meter. Because if you do that and you go to measure voltage, again, the shunt in here, if you're not measuring current through it, is pretty much a dead short for anything else that you want them to measure. I'm not going to do that to this meter because I don't want to, blow and have to replace this fuse again. But for a lot of meters, if you mess up and leave this in amp mode or leave the test lead over here and measure something, a lot of meters, even though they have an internal fuse, they don't recover from something like that. Now, I've done it with this fluke, and this particular fluke's been fine. I've changed this fuse out, and the meter itself is perfectly fine with no issues. But again, it's a bit higher meter. It's a bit more stout. So again, just keep that in mind. I can't emphasize that enough, that if you're measuring amps with this, always remember to switch that test lead back to its original position. So with that being said, looks like we're about 38 minutes into this according to the camera. I'm hoping that helped explain things a little bit, because to recap, we went over just measuring basic DC voltage, positive and negative. In DC's case, like you saw, if you have your test leads hooked up backwards, then it'll tell you you've got a negative voltage, meaning your positive and negative test leads are the other way around with what you're measuring, or what you're measuring is labeled wrong. And then we switched over to continuity to check the status of a circuit. In other words, let's say we've got a circuit and we're troubleshooting a lock actuator in a door, and it tells us pin 1 or the wiring diagram should go to ground. So we probe pin 1 on our wiring harness, and we touch the body, what should be a good known ground, and we don't get any continuity. Meter says 0, it's not beeping. We know we got a ground side issue with that circuit. Or it doesn't beep, but we get a resistance number. Could also indicate a high resistance. So it gives you an avenue to know kind of where to start next, where to go next. You can also use the connectivity, as we saw, to do basic things like test a fuse. Again, take it out of the circuit before you test it. Test the validity of a light bulb, whether the filament is good or not. And the last thing that we looked at was doing amps DC through the meter to, as a test, look at the power draw of a LED tail versus a standard incandescent turn signal bulb. You'll notice 1 point something amps for this one, only, what was it, 0.16 amps for this one. But it tells you a lot. It can tell you potentially how much current a new set of lights maybe you're debating on putting on your vehicle will pull. You can also use it, like we discussed, for checking the current of any circuit in the vehicle. But remember, you're putting this in series with your load. But you can also use it for checking the sleep draw of a vehicle. Again, maybe you're troubleshooting a parasitic draw where overnight your car battery keeps dying, and you put your meter in line with the battery, or the negative post of the battery. Remember, negative. Remember, that's going to go to your power source. That's going to go to your load side. And you can look at that to tell, is everything going to sleep? Are you seeing the sleep current draw that you should see? Or is it staying up around 2, 3, maybe 4 amps and overnight draining your car battery? Kind of confirming that you've got something in the car that's either staying active or not going to sleep, or has a slow short to ground, things of that nature. And that was pretty much the areas that we covered. Very, very basic, very, very high level. I freely admit that. But there are other things that you can do with the, like let's say the resistance settings on the meter, just to give you a brief overview. You can use it to look for, like we said, high resistance connections to ground. You can also use the voltmeter function, just again looking at volts DC, to measure the voltage drop across the cable, again, which could also indicate a high resistance connection to a particular item. That's getting a little bit more into the upper, you know, I don't want to say the more advanced things, but it's getting a little bit beyond the basic realm, but not too far. But hopefully that helps. Hopefully that kind of shows you some of the basic overviews that I'm doing here. Like I said, again, it's just some of the basic things that I use when I'm doing some of my automotive troubleshooting here, especially obviously when it comes to wiring and electrical circuits and things of that nature. If you have a manual meter, analog meter, obviously things are a little bit different. I don't see too many analog meters these days, but they do exist for specialty reasons and nostalgic reasons. I used to have an analog meter. I still wish I do. I actually kind of like analog meters myself. But to answer one final question here, again, you don't need an expensive Fluke 117 to do most of these functions. So let's tell you what. Let's move that out of the way. Let's just say you didn't have that. Let's say you had this little guy here. This is just a little Craftsman meter. Got this one again about 20 years ago, maybe a little over 20 years ago at this point. It was a Black Friday deal. I want to say this was 10 bucks. I can do almost everything that I did with the bigger Fluke that I did over here, except one thing that you cannot do. Current measurements on this one. This is not going to handle up to 10 amps. Obviously. But for the other items that we were playing with, say you want to measure volts DC. You notice you have fewer areas to turn this lever. Like this area does volts AC and DC. Right now, if you can see that, that's in millivolts. But if I hit select, I'm now in AC volts, if you can see that over here. I'm now in DC. So AC and DC. So I'm going to go back and make sure I'm on DC. And this should auto arrange. Once again, I'm just going to take our laptop power supply here, which is set to about 12.5 volts per its readout. I'm going to hit negative to negative. Positive to positive. And you can see it is auto arranged out of millivolts and is showing us 12.47, and the laptop power supply says 12.5. So it's not too far from being bang on the money, at least agreeing with what the laptop power, I should say bench power supply, is showing. Now, again, small little meter, but it gets the job done. Doesn't need to be the big, more expensive Fluke type or other brand of meter. And like I said, this one's been about 20 years old at this point, and more often than not, if I'm just doing a voltage check or a quick continuity check, I'll actually just grab this meter instead of grabbing the Fluke, because it's smaller, lighter, and like I said, will get the job done for us. It'll also measure hertz. It'll also do resistance, continuity, diode, and it does do a little bit of current, but like it says there, milliamps of current, not amps. So to show you that, I'm going to again disconnect my meter, make sure I'm disconnected before I change this over. Come over to here. Now in order to select that, I'm just going to keep hitting my selection until I see that little wavy symbol like you saw on the other meter. And you'll see the resistance horseshoe there on the right hand side. And if I touch these together, it beeps. And you'll see that readout will slowly get down as close to 0 as possible. But again, touch leads aren't the greatest, but I don't need it to be 100% accurate. If I've just got a fuse I've pulled out of the fuse box and I want to test it real quick. Okay, gets the job done, beeps, lets me know that it's reading connectivity across those blades of that fuse. The light bulb is no different. Well, let me get that down where you can see that. Okay, there we go. Reads continuity just fine. Gives you that beep, gives you that audible tone that you may be looking for. And like I said, the only thing that I can't do with that one is measure those bigger amps, as in this one will only handle milliamps. And to be honest with you, I don't even use it for doing milliamps, because if I'm doing work on this, it's generally measuring some type of DC voltage and or some type of continuity. Maybe the diode checker on there if I'm checking out diodes on something, but again, that's a little bit more on the electronic side of it, and or if you're troubleshooting a module that maybe you've taken apart out of a car. But just wanted to show you that even a basic meter these days will have a lot of the functionality in it that you could probably ever want when troubleshooting a vehicle. But like I said, if you're going to get into more of the advanced stuff where you want to see a waveform from, let's say, a crank position sensor or a cam position sensor, or see communication across the CAN bus, you know, you're going to want to either A, have a meter, or B, some type of a scope that can show you that form. But if you're just looking to do, you know, what I would call basic voltage measurements, basic continuity checks, and in some meters cases, you know, basic amperage checks, like I said in this case, up to 10 amps on this particular Fluke, then a standard meter will get done what you need to get done. Hopefully that was helpful. Hopefully you stuck around for this kind of a rambling rant. If you want me to go into a bit more in-depth on this, I'll be happy to do so. We can also set up a few more in-depth demos as well. If you haven't subscribed already, please consider to do so. Still continuing to grow the channel in order to allow us to do more elaborate builds, more elaborate tests, and instructions such as these. I will also say that YouTube is phenomenal for this type of stuff as well. There are several individuals who do electronics blogs, and if you watch their videos, there are several individuals out there that cover meter usage as well. Now, when you get into the electronic side of it, it kind of gets more into the advanced functions and theories and such. But again, as you see here, a standard meter that you get off of Amazon for, $40-50 will more than likely do what you need it to do. When you look at one last thing about meters, I'm sorry, I'm going on a little bit of a tangent. One of the big things about the difference in the qualities of the meters has to do with its accuracy and its resolution. If you're getting into the higher end stuff, where you're troubleshooting power supplies and some form of electronics, then maybe having a 6, 7, 8 digit meter is what you need, because you need that level of resolution to verify that the schematic says you have 5.512 volts, that you actually have 5.512. But for most of the stuff that you deal with in troubleshooting automotive, now not in all cases, because again, automotive deals with computers and sensors which get picky about their voltage, but in most cases, at least the stuff that I find myself troubleshooting, having this little meter here on the table or this fluke here generally tells me with fairly high accuracy enough that if I'm supposed to get battery voltage of 12 point something volts at a pin, then I'm seeing what the schematic says I should see at a particular pin. With that being said, I'll let you go and stop rambling here, but if you want to see any more to this, just let me know. If you want to see a particular item about a meter, just throw it there in the comments, and I'll do my best to address it. In case you're curious, that is the 10 amp regulated power supply that we were using for our testing. You can get these super cheap on Amazon. If you don't have one and you want to test automotive lights and things of that nature, as well as other items, I suggest that you get one. Like I said, it'll handle up to 10 amp. This particular one will do 10 amps maximum, and the voltage it will go up to, if we go all the way to the top end, looks to be 32 volts at about 10 amps. And how you actually calibrate the amperage on here, because you can dial in the amperage just like you can the voltage. If I go back down to 12 volts, and this is going to seem weird when you see me do this, I'll shut the power supply off. I'm sorry, bonus content. I know I'm rambling. I'm gonna short this together. And that's right, I said short together. Turn it back on. You'll notice we're now on amperage mode, constant current mode, not constant voltage. And then you can dial in what you want the maximum amperage to come out of this power supply to be. So let's just get close to 5 amps here. There's a coarse adjustment and a fine adjustment. This is your coarse adjustment. This is your fine adjustment. Fine adjustment, as you see, will adjust to 0.01 of an amp. And then when you get them dialed in where you want it, you unshort it. You see our amp draw is now at 0, and we're now back in constant voltage. So this is what's known as a constant voltage, constant current power supply. So this one is, again, capable of feeding up to 10 amps of current. And I have used this one on the gray truck out there. I set it to a maximum of 12.5 volts at 10 amps, and that's what I was using when I was testing the blend door actuators and such inside the vehicle. Now I'm getting an actual, 20 amp automotive grade power supply to do the further testing, but just to give you an idea. Like I said, these are super helpful to have, especially if you're just, testing lights and things of that nature, because you can dial in kind of what you need. But I'll put a link in the description of where I've got this one. But if you just search on Amazon for 10 amp lab or desktop power supply, you'll get all kinds of these will show up. With that being said, I'll let you go. Like I said, if you found these useful and you hung on this long from my rambling, please consider subscribing if you haven't done so already. Also, if you want me to continue to do more items like this or drill a little bit more in depth, let me know. Throw it in the comments below, and I'll chat you later. Thank you much. Bye.